So the heritability of a trait tells us the proportion of genetic variation that there is for that trait compared to the amount of other variation or phenotypic variation. So what phenotypic variation means is basically the genetic plus the environmental plus management plus herd effects, those sorts of things. So traits like fertility have small heritabilities, typically around about 5%, because most of the control of those traits is management or environmental, although there is a genetic component there that we use, say, with fertility breeding values to select for. Now, an interesting, I suppose, concept to get over is that even if a trait like fertility has a low heritability, there may still be a large amount of genetic variation. So this sounds a bit strange to start with, but if you think about it, all it means is that the amount of other variation is massive in comparison. So it means that there's big differences between the best and worst bulls for fertility, but that you have to, I suppose, be fairly firm with your selection principles in order to make genetic improvement in this trait. So just using fertility as an example, we've shown over the last 3 or 4 decades that there's been a deterioration in fertility, both at the genetic and phenotypic level, but at the same time, we've been able to use breeding values to reverse this trend. So it's important to keep sufficient selection pressure on this trait to make genetic gain. And that's one of the functions of the BPI index, is to make sure that fertility has a strong place within that index and that we continue to make genetic improvement